Good afternoon, evening, night, morning, breakfast, brunch, lunch, dinner, whatever time of the day it is for you. It is the best time of the day for me because I get to make a video and I get to act like a fool, just like I usually do. Anyways, hopefully you're used to that. Hopefully Old Pike still acts like a fool. Anyways, you don't really care about that. So, in this video, I'm going to be talking about 5 multiple angle identities. This is going to be half angles. This is going to be double angles. So, make sure you're looking on your sheet. The double angles are on top, the ones like sine of 2x equals 2 sine x cosine x and cosine 2x and tan 2x. The half angles are the ones that you're going to be taking your angle and you're going to be making it half. So, at the bottom of your sheet, sine of x divided by 2 equals plus or minus blah, 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 blah. Whatever, okay? Depending on what situation we're in is dependent or will determine what function that we use. So I'm just going to jump in and start doing a bunch of examples with these things. Alright, so our first example, we have a triangle. We have 1, 4, and by Pythagorean theorem, this side is going to be square root 17. I want to find sine of 2 theta and cosine of 2 theta. So if I want to find sine of 2 theta, I have no idea how to do 2 theta. I can't just make this a bigger triangle or anything. But I do know that sine of 2 theta, by my identity, is equal to 2 sine theta cosine theta. So since that's true, I know I can find sine theta and cosine theta. So just looking at your triangle, sine theta, from here, opposite over hypotenuse is 1 over 17. So I have 2 times 1 over root 17. Cosine is adjacent over hypotenuse, so 4 over root 17. Okay, so now I have, if I multiply these two things together, I'll have 2 times 4 over 17. 2 times 4, well, that's 8, so this is going to be 8 over 17. Cool, that's sine of 2 theta. Looking at cosine 2 theta, you can use any one of these that you are comfortable with. We have 3 different identities possible. So really, honestly, it makes no difference in the world which one you use. They're all going to be the same answer. So I'm just going to use the top one. Say I do 1 minus 2 sine squared theta. So I know sine theta, oops, I didn't put my squared. Sine theta is 1 over 17. So substituting in 1 over 17, 1 over root 17, I have 1 minus 2 times 1 over square root 17 squared. Now if I square 1 over root 17, 1 squared is 1. Square root of 17 squared is 17. So this is just 1 over 17. I have 1 minus that. Okay, well now if I do 2 times 17, this is 1 minus 2 over 17. I don't know what that is. Make it seem like it's a banana. Banana, banana, banana. I don't know why that was necessary. I apologize. So in order to add or subtract fractions, these are ones that I do want you to be able to do. I need to get a common denominator. So 1 is 17 over 17. So 17 over 17 minus 2 over 17 will be 15 over 17. And there we go. So I have cosine of 2 theta and I have sine of 2 theta, and happy day, sad day, glad day, mad day. Get some trash bags, make it a glad day. Okay, on examples like this, really take your time, write it out, and think about what I'm saying. Try to think about everything that I say after I say it, because these are a little bit abstract. So here I have sine of 2x plus cosine of x equals 0, and I want to find all of the angles between 0 and 2 pi that work for this equation. So first thing I'm going to do is try to substitute something so that hopefully I can get something in terms of cosine x. I know sine of 2x, I only have one identity for it, so I have to use the identity that this is 2 sine x cosine x plus cosine x equals 0. Since that's true, I can take out a cosine x and factor it out so that I have cosine x times 2 sine x plus 1 equals 0. And now I have something times something equal to 0, so cosine of x equals 0, and 2 sine x plus 1 equals 0. Okay, cosine of x, for that to be 0, think about your unit circle. You have 1, 0, you have 0, 1, negative 1, 0, and 0, negative 1. So for cosine to be 0, that is your x value. That's going to happen at straight up and straight down. So yo homie G, we got squared up, squared down, pi over 2, 3 pi over 2. There are two solutions. Solve this one for sine. So get sine by itself first, so you have sine x equals -1/2. This is going to come straight from your triangles. In order for it to be -1/2, you have all sombreros, try chimichangas. Sine is negative in the third and fourth quadrant. So let's see. Oh yeah, I need to look at a triangle. Triangle, triangle. Everybody loves triangles, especially triangles. 3 points where 2 lines meet, and if anybody gets that reference, check out Tessellate, all J. I kind of like it. So if I use this, my pi over 6, I have 1, root 3, 2. Sine is opposite over hypotenuse, so I want this to be my opposite side. I want this to be my hypotenuse. The only angle that that works for is my pi over 6, so there's my reference angle. So theta is pi over 6. So I'm going to be pi over 6 away in that direction, pi over 6 away from 2 pi. So x will also be 7 pi over 6, and let's see, 11 pi over 6. That's a 2. Why would you write 2, you crazy little old man, even though you're not that old yet? Maybe one day. Ha. And you would have 1, 2, 3, 4 soluciones. Alright, this one's going to be a weirdo. He doesn't like ketchup, so he's just a little bit weird. With this, I have sine x and cosine x multiplied together, so I can't really factor anything out. I can't just multiply by the only thing that I see, that I notice, is I have sine x times cosine x. So what I can do is, I have the trig identity 2 sine x cosine x is sine of 2x. So that would get it down to one trig function, which would be really cool. So if I factor out a 2 and make this look exactly like the other side, that 2 sine x cosine x equals 1, then this whole part right here, I can substitute in sine 2x. So I have 2 sine 2x equals 1, and now I have this as my only angle. So what I can do then is divide by the 2, so that I have sine of 2x equals 1/2. But what the heck, Mr. Pike? We don't know how to do 2x. Well, here's the thing. If we have a 2x instead of an x, if we're trying to find between 0 and 2 pi, to get to 2x, I multiplied the middle by 2, yeah? So then I'm going to be looking for solutions for 2x between 0 pi and 4 pi. So if I multiply this entire thing by 2 to kind of get my restrictions, and then I'll be able to divide all of the solutions that I get by 2. So just check this out. Check it out. I don't know sine of 2x, but I know sine of some angle to be 1/2. I can use my all sombreros, try chalupas, chimichangas, cheesecake, cortisone, whatever you want. I don't care. However you remember it, whatever. And I have the triangle of this guy. So I have pi over 6, pi over 3. Sine is 1 over 2. That's root 3 because it's across from the pi over 3. But I want my opposite side to be 1, my hypotenuse to be 2. So I'm going to use my pi over 6 as my reference angle. Sine is positive in this case. It is positive in the first and second quadrants. So I have the values 2x equals pi over 6 and 5 pi over 6. But hang on, we got to keep going and find more coterminal angles, because we got to go all the way up through 4 pi. So I keep going around 2 pi, so I'm going to have to go around again. Well, if I add 12 pi over 6 or 2 pi to pi over 6, that's going to get me to 13 pi over 6. Same thing, if I add 12 to 5, because that is a full circle. A full circle in terms of over 6 is 12 pi over 6. So if I'm just getting my coterminal angles, then I can also have 17 pi over 6. That's right in green. So 17 pi over 6. But I don't want to know what 2x is. I want to know what is x. What is the value of a single x? I mean, that's what we solve for. We solve for x. So in order to do that, if I divide this by 2 or multiply it by 1/2, same thing, then I'm going to multiply every single angle by 1/2. So really this will be pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. So that now all of my angles are between 0 and 2 pi, because I divided it by 2, and they will all check out. You can double check your work. Try to plug them in the calculator. See if you get the answer of 1. But I promise, it'll work out. Be very careful when you have a double angle. Make sure you keep going all the way through your double angles or whatever angles restrictions. Oh, I need to have a function. Let's say 6 cosine squared x minus 3. Okay, and we're going to try to write this thing as a single term because he's trying to get a divorce from whatever and just go off on his own, and I don't know. It's a sad day for this term. But if I want to get it as a single term, I see that I have cosine squared. So it looks kind of like the middle one where cosine 2x equals 2 cosine squared x minus 1. So if I can get it to look like 2 cosine squared x minus 1, I know this is equal to cosine of 2x by my identities, and this would get it down to a single term. Well, check it out. I have a 6 and a 3, so if I can factor those things out so that I would have factor out a 3, this would be 2 cosine squared x minus 1. Well, then it's just a matter of substitution. This is cosine 2x, so I can say 3 cosine 2x. He's all by himself. He's happy. He's not having to deal with anything being thrown at him. I don't know. Whatever. It's a happy day for this function. Hee! Happy! Alright, another type of example. It'll ask you for, kind of like in the last unit, how we, or not last unit, last section, how we had to look at a triangle. It gives you cosine of u is negative 2/3. Sorry, didn't mean to draw that. I'm just making stuff up. Cosine of u is negative 2/3. We also have this restriction right here. U is between pi over 2 and pi. All that really means is that u is in the second quadrant. So when you draw your triangle, just draw it up in the second quadrant. So here is u, your reference angle to the x-axis. You have adjacent, it's going in the negative direction in the x, so negative 2 and 3. That's a double 3 because it's double cool 3. And then by Pythagorean theorem, you will have this side to be square root of 5. It's going up, so it's positive. We're good there. And then I want to find sine of 2u and tangent of 2u. Well, by our identity, sine of 2u is equal to 2 sine u cosine u. So I will have 2 times sine of u. Well, sine of u is opposite over hypotenuse, so root 5 over 3. Cosine of u is adjacent over hypotenuse, so negative 2 over 3. Multiply these two things together, so you'll get 2 times negative 2 root 5 over 9. And then 2 times negative 2 will be negative 4 square root 5, come on, over 9. There is sine of 2u. Now I'm going to look at tangent of 2u. So for tangent of 2u, again, just make sure you guys use these formula charts. If you don't know what to do, look at the formula chart, see if something might make sense there. So tangent of 2u is 2 tan u over 1 minus tangent squared u. Yes. Tangent, opposite over adjacent, so root 5 over negative 2, so it's going to be negative root 5 over 2. So I have 2 times negative square root 5 over 2 on top over 1 minus negative square root 5 over 2 squared on bottom. So on top you have 2 minus root 5 over 2 over, this will be negative root 5 squared will be 5 over 4. So you have 1 minus 5 fourths. And then it's just a matter of getting common denominators and adding and subtracting things together. And then I'm good with that. Cool. Happy day. Well, let's actually do it probably. Yeah, so 2 in terms of over 2, that would be 4 over 2. and 1 in terms of 4 would be 4 over 4. So I will have 4 minus root 5 over 2 on top, over 4 minus 5 is negative 1/4 on bottom. I'm sorry, I'm running out of room a little bit. Okay, and then if you multiply by negative 4 over 1 and negative 4 over 1, that'll go away on bottom. It will stay on top. 2 divided by 4 is 2. And then 2 times 4, notice it's a negative 2, will be negative 8. Negative times a negative is a positive, so plus 2 root 5 all over 1. So nothing. That's your answer. Cool. Hopefully we don't have to do tangent that much because tangent is fun. We love tangent. Yay! All right, now I'm going to look at some half-angle identities. Again, you're given a triangle. You have 8, 15, and by Pythagorean theorem, I believe this will be 17. I don't know why I did that. 17. So find sine of theta over 2. So sine of theta over 2. Just use your identities. So that is plus or minus the square root of 1 minus cosine of theta over 2. So 1 minus cosine theta is adjacent over hypotenuse, so 1 minus 15 over 17 over 2 square root plus or minus. Okay, common denominator on top, you'll have 1 is 17 over 17. So 17 minus 15 will be 2 over 17. So you have plus or minus root 2 over 17 divided by 2. So when you multiply by 1/2 on top and bottom to get rid of this 2, you have 2 and 2, 2, 2. So you have plus or minus the square root of 1 over 17. Cool, that's just using your identity and simplifying. You guys should have some idea of how to simplify this, hopefully. It's just Algebra 1 skills. Okay, with secant, this is going to be a little bit weird. I don't have an identity for secant, but I can find 1 over cosine theta over 2. Or I can find cosine theta over 2 and then just flip it for secant. So for cosine of theta divided by 2, I have plus or minus the square root of 1 plus cosine theta all over 2. Again, cosine theta is going to be 15 over 17. So these are going to be very similar in the values. So plus or minus square root. I'm going to go ahead and not write a 1 and just change it to the 17 over 17 that I did on the other one. So 17 over 17 plus 15 over 17 divided by 2. So I have plus or minus the square root of 15 and 17 will make 32 over 17 over 2. Divide that by 2, it'll be 16 over 17. So I have plus or minus square root of 16 over 17. And then for secant, make sure you flip this. Make sure you say plus or minus 1 over square root 16 divided by 17. Cool? Awesome. Perfect. Sorry this video is going so long. I'm trying to talk fast for you guys. Alright, for this one, determine the exact value of sine of 165 degrees. Well, if I think about 165 degrees, that is in the second quadrant, and I have a reference angle there of 15 degrees. So that does me no good, so I'm not going to use this one. However, I see that 165, if I'm thinking about double and half angle identities, if I double this, so I say sine of, what is that, 330 divided by 2. 330 divided by 2 is 165. I can find 330 because 330 is in our fourth quadrant with a reference angle of 30 degrees. So I have ASTC, I have a triangle. Wow, I have no idea what that was. I don't know if you even heard that. Some person screamed. I hope they're okay. I should probably pause the video and go do that. Okay, yeah, everything's good. Interesting. Sorry. So sine of 330 divided by 2. So really, this is going to be our identity. So I'm going to use the identity that sine of theta over 2 is plus or minus the square root of 1 minus cosine 330 over 2. Cosine of 330 degrees is going to be positive by this right here, since I'm in my fourth quadrant, so it'll be positive, whatever it is. For 30 degrees, cosine is adjacent over hypotenuse, so root 3 over 2, so I have plus or minus square root 1 minus root 3 over 2. All of that divided by 2. And you know what? I'm happy with you guys just leaving it like that. Yay! Alright, that's all I'm going to do for you guys today. Just make sure you really think about these identities. That's all we're doing over and over and over again, is just using these identities to rewrite the problems. And hopefully this was somewhat helpful. And just for that, I will give you a picture of a giant with a long tail holding up a magnificent red banana, a happy monkey. Thank you guys for watching. Well, bye now.